Welcome back. This is Mr. Anderson from Cal Community College looking at our second half of our Chapter 2, Section 1 workout, looking at some degrees and radians of circles. What we're going to do is convert each angle from degrees to radians, and we're going to express all our answers in decimals, so we're not going to have anything in units of pi. So like we did in the previous video, we're going to multiply by pi over 180, but we will do some approximation. 73 degrees, or 73 times pi divided by 180 gives you an approximation of 1.27 or 2700 hundredths of a radian. Alright, now if we do the same thing here, multiply by pi over 180, we're going to go and get an approximation of negative 0.89 radians. And do the same thing here, multiply by pi over 180, and we get to 6.11 radians. It goes to show that 360 degrees would be approximately around 6.2 radians, so 350 degrees is pretty close to that. And I think a lot of us think like, oh well, a circle is 2 pi times 1 for the unit circle, but if pi is approximately 3.14, so there's where we get our close to 6.2 radians for a complete circle. Same thing here as we did before, except we are going to multiply by 180 and divide by pi, and this will give us an approximate degree measurement. This one would be 42.97 if rounded correctly. So 2 decimal places, as it says in the instructions. This is going to be 180 degrees divided by pi. Again, 3 times 180 divided by pi is approximately 171.89 degrees. Square root of 2 radians? Sure, why not? We're going to multiply by 180 divided by pi, and this is going to give me 81.03 degrees. Alright, so moving on to our next piece here, we're going to take a look at finding arc lengths on the edge of a circle, and a couple little neat things to think about here. A circle, if I go through the entire thing here, my circle is 360 degrees. So the circumference of a circle is 2 pi r, but since we're working with a unit circle, let's go with 2 pi 1. But I'll put the r there just in case if you're not dealing with the unit circle. Now, if we want a sector of a circle, we can create that using the central angle theorem. The sector of the circle is going to be comprised by the theta, or the angle that's created by this sector here, or pizza slice, if you want to think of it this way, and this s is going to be that arc length on the outside. The arc length formula is going to be radius of the circle, since it may not be 1, times that inside angle right there. And that inside angle must be in radians. This is a very important thing. So theta must be in radians, not degrees. And many geometry textbooks actually use formulas that are based on degrees instead of radians. So that might be a little bit of a twist that we can explore maybe in class or through email. But just to get to the raw format here, we're going to use our s equals r times theta for each one of these problems. So we're going to try to find that area of that little arc on the outside of the on the circle here. So how much crust is there if we have a 6-foot radius pizza or 12 feet wide diameter pizza, and the theta, or angle, is 2 radians? Well, we can convert that easily. We can go the s is equal to, or the crust is equal to 6 times 2. Of course, the units here, I'm not putting them in because it's pretty easy to figure out that if you're talking about everything in terms of feet, our s is going to be equal to 12 feet of crust on this little pizza here. That's, little being sarcastic. But again, you can put your units in here. You can see that there would be some simplification as we work through by putting feet in, and this radians would simplify with the s radians here, which will leave me with feet if I move the radians to the other side. So let's look at this here. We're going to go with pi radians, we're 1/4 radian, and then we have 6 centimeters for our s. So here we have our formula, s equals r theta. We're going to plug our 6 in this case into our s, because that's how much crust we have on the outside. We don't know the radius of the circle, but we do know this is 1/4 radians here. Now to get the r by itself, we're going to multiply both sides by 4, so r is equal to 24 centimeters. Because 1/4 on both sides, 4 times 6, 1/4 times 4, this simplifies to make 1. Alright, so s is equal to r times theta here. So here we know our little crust edge is, or that little arc length is 8 meters long. We know that the radius is 6 meters long, but we don't know what the theta is. So what we're going to do is divide both sides by 6. So what we have here is theta is equal to 8/6, which is, since we're supposed to round to 3 decimal places, 1 333 thousandths of a radius. And then finally, this last piece. Now, this last piece takes into account that, hey, you know that theta has to be in radians, so we're going to do a little quick conversion. We're going to take this from 120 degrees and multiply by pi over 180, which gives us an approximation of 2.094, rounding to 3 decimal places, or 94 thousandths. So what we have here is r is equal to 3, theta is equal to 2.094 radians, and so now we need to find s. So the equation is s equals 3 times 2.094 radians, and we get an answer of 6.283, or 283 thousandths of a meter. Alright, now our final 4 problems is going to look at, instead of an arc length, which is the crust of the pizza, we're going to look at the sector, which is going to be a and again, I'll just read this here. The sector is like the whole slice. It says the following A denotes the area of a sector of a circle with radius r subtended by the central angle theta. So that's the center of the picture there. Find the missing quantity. Round answers to 3 decimal places. So let me bring this all in here and show you the little difference here. Now in this case, let's kind of think about our area of our circle. The area of a circle is pi r squared. And what we want here, instead of the whole circle here, is we want a little pizza wedge. And that little pizza wedge has an S for a crust, but we're trying to figure out the area inside the pizza wedge. Now, we have to define this in terms of radians again, so there's theta inside. And understand that triangles are similarly based. This is kind of a triangle. So if you think of a triangle's area from your basic geometry class of 1/2 base times height, the area of this sector is going to be 1/2 the radius squared times theta. And so let's go and compute this now and take a look and see how we can get our answer here. So we're going to find the area if our pizza had a 12-foot diameter or 6-foot radius. And we're going to look at 1/2 6 squared, and we're going to choose an angle that's 2 radians big here, so we're going to multiply that by 2, and so this leaves me with 1/2 of 2, which is 1 times 36, so this is 36 feet squared. And it's feet squared because the radius is squared, and you have to think that there are 36 square feet inside this circle area here, because area is always a second dimensional object. So looking at the formula again, in this case we're going to go with, I'm going to write down the original formula just so you can keep seeing this here, r squared theta. I'm going to plug my a here, which is 6. My 1/2 is going to stay 1/2. We don't know my r in this case, so we're going to have to square root to get r by itself, and we have 1/4 of a radian. We have 1/2 times 1/4, multiplying fractions, not a problem. Top times top, bottom times bottom. And to get rid of the 1/8, we're going to multiply both sides by 8. 1/8 times 8 is 1. 8 times 6 is 48. 48 is equal to r squared. We're going to square root both sides of r squared, which gives me plus or minus, and I'll eliminate the minus since we are dealing with a geometry problem here. So this gives me the square root of 48. So r is going to be approximately the plus, not the minus, 6 and 928 thousandths of a centimeter. And radius is a distance, so radius is not, that unit is just the distance from the center to the edge. All right, getting a little bit more complicated here. We're going to find out how many or how big this wedge is in radians. So we're going to start off with our area, it being 8 square meters. Then we're going to take 1/2 of our radius. Our radius is going to be 6 meters, and then we'll isolate the theta to figure out how many radians is in this arc sector. So we're going to start off with A in this case, which is 8, is equal to 1/2 6 squared, which is going to be 36. I'll just skip that step if you don't mind. 1/2 of 36 is 18, so 8 equals 18 thetas. Divide both sides by 18, so now we have 8 eighteenths, or approximately 444 ten-thousandths of a radian. And there's my theta. To finish up our worksheet here, we're going to take a look at this problem again. Like the previous one here, we do have to do some conversions, so if you want to rewind the video to what 120 degrees was in radians, be my guest. But I will write down our quick answer that 120 degrees in terms of radians as a decimal is 2 and 94 thousandths. So our A is going to be equal to 1/2 our radius squared times theta. So our area of our arc sector is going to be 1/2 times 3 squared times 2.094. So you multiply all these together, you get an area of approximately 9 and 423 ten-thousandths of a meter squared. All right, well, thank you for watching.